Good day and Salamat Sejahtera to Mr. Muhammad Fairuz and Dr. Ashrin. I'm Lee Jing Yao from 4BKGS3. Today I'm here to present my FYP2 presentation with the title of Artificial Bee Colony Optimization Algorithm with Application to Engineering Problem. The problem statement in this project is a lightning detection and analysis system LDAS that innovates is not accurate in the lightning strike location detection, and the proportional integral derivative PID controller that control the hub angle of flexible manipulator system FMS is not easy to deal in manually. There are three objectives in this project. The first objective is to investigate the performance of ABC algorithm with different parameters and using different benchmark function. The second objective is to investigate the performance of ABC algorithm in LDAS and Boltec LD350 system that detect the lightning strike location. The third objective is to investigate the performance of ABC algorithm in the control of FMS with suitable performance criteria. So, what is optimization and what is algorithm? Optimization is a process to finding the best solution out of all feasible solutions of defined problem, where algorithm is a well-defined computational procedure that takes a set of data as input and produce some value as output. Basically, the optimization algorithm is the algorithm to solve the optimization problem. There have many optimization algorithms in this world. Well, the optimization algorithm that I choose to be used in this project is ABC optimization algorithm. This is because, previously, some of the researchers investigated the optimization algorithm in LDAS and FMS by using swarm-based optimization algorithm. ABC optimization algorithm is also one of the swarm-based optimization algorithm. That is the reason why I choose it. ABC algorithm is motivated by the intelligent behavior of honeybee and defined by Davis Caraboga in 2005. Generally, the aim of this bee is to discover a food source with high nectar amount and find the highest nectar food source at the end. Benchmark function is the test function to test the performance of the algorithm in terms of robustness, converging rate, and stability. In this project, 8 common benchmark functions are used to test the ABC algorithm by varying the parameters and the converging rate is observed. LDAS is a system that can detect the lightning strike location with capacitive antenna and lobe antenna. The lightning strike location can be calculated by using calculation formula with the magnitude of peak voltage that captured from the graph of electric field and magnetic field. The peak voltage of electric field and magnetic field is the parameter that determines the lightning strike location which need to be optimized and calculated to get closer with the lightning strike location data that get from Boltec LD350 system. Due to the data that we get from Boltec LD350 system is the benchmark that we refer in this application. FMS is one of the newly introduced features that used in many applications such as robotic arm, waving mechanism, spacecraft antenna, telescopic member, and etc. The PID controller is used to determine the hub angle of FMS. In this project, ABC algorithm is used to deal the gain factor of KBKIKD in PID controller to optimize the hub angle performance of FMS. Well, the hub angle performance of FMS is measured with different performance criteria such as ISE, MSE, RMSE, IAE, and ITAE. To achieve the first objective in this project, a set of benchmark functions need to be selected before running the ABC algorithm and use only one benchmark function for each type of test. For each type of benchmark function, the ABC algorithm will run in 30 independent runs to test the robustness of the algorithm. This process will be repeated after each time the change of parameters for every type of benchmark function that used to be tested. After that, the solution will be recorded as a set of data and categorized to compare the standard deviation, average, minimum, and maximum of the solution values. The conversion plot is plotted after the algorithm finish run to show the performance of ABC algorithm in the rate of convergence, which tests by every benchmark function that's selected. To achieve the second objective in this project, the lightning strike waveform should be collected by using the capacitive antenna and lobe antenna of the LDAS. All the lightning strike waveform is displayed by using Pico oscilloscope along buffer circuit. After the image processing process by using MATLAB, the peak voltage of the electric field waveform and both magnetic field waveform will be recorded to calculate the lightning strike location. The area of the detection for lightning strike location is measured by compare the recorded data that detected by LDAS with the data that get from Boltec LD350 system. The ABC algorithm is run in 30 independent runs by using the objective function that created and the parameter is set after each 30 independent runs. The data is collected for each 30 independent runs and the variable with best objective value are selected and compare it with the variables that detected by LDAS. The variables for the application are referred to the peak voltage of electric field and magnetic field waveform. Thus, the percentage of the area for landing strike location can be calculated after comparison between both sides of data, and tuning for application can be made. To achieve the third objective in this project, the ABC algorithm is run in 10 independent runs by using the objective function and a simulating model of FMS that created. The parameter is varying after each 10 independent runs. The data is collected for each 10 independent run and tabulate the result according to the categories of parameters that varying. The KP, Ki, and KD with best objective value are selected and used in the simulation for half angle of FMS. The step response characteristic is referred to the rise time, setting time, steady state error, and overshoot. Thus, the step response characteristic can be evaluated after the simulation done. Besides this, the best half angle performance of FMS can be concluded by set condition to analyze the performance criteria. The result of investigate performance of ABC algorithm by varying the parameters show that when the number of iterations is increased, the objective value, the standard deviation, and the average are decreased. This is because the number of iterations of the ABC algorithm with the selected benchmark function is increased. Next, when the number of dimensions is increased, the objective value, the standard deviation, and the average are increased. This is because the objective value is become harder to reach the global minimum point as the complexity of the objective function increase, and the range of the objective value for 30 independent runs is become high. Well, when the number of foot is increased, the objective value, the standard deviation, and the average are decreased. This is because the number of solutions that randomly distribute in the process of food source initialization is increased and easier for employed B and onlooker Bs to find the best solution. The consistency of ABC algorithm to obtain the same objective value is also increased as the mean value decreases. To tune the peak voltage of electric field and magnetic field of LDAS for increase the accuracy of landing strike location detection, 11 landing strike data are collected at the same time from the fast field of LDAS and Broadhead LD350 system on the date of 4 March 2020 to have a fair comparison between apple and apple. The average distance and bearing angle after optimized had improved in compared with Broadhead LD350 system. Generally, the latitude and longitude for the lightning strike location should have improvement when the bearing angle and the distance of lightning strike location are improved after optimized by using ABC optimization algorithm. However, the results show in opposite. The reason of this abnormal situation happened because the latitude difference of last 4 lightning strike data are too wide. This is because both LDAS and Broadhead LD350 system might have time drift when capture the lightning strike data. Time drift will cause the lightning strike data capture time difference with each other system. At the same time, the high average bearing angle difference will also increase the average difference of longitude after optimization. The objective value for last 4 optimized lightning strike data are extremely higher compared to others. The higher the objective value, the less accurate the peak voltage of electric field and magnetic field that obtained after optimized by ABC algorithm. The inaccurate peak voltage of electric field and magnetic field will cause the abnormal difference in latitude and longitude for the lightning strike location after optimization. In comparison with the lightning strike location data from Broadhead LD350 system, the average distance and bearing angle after optimization have better performance, so that the percentage of peak voltage for electric field and magnetic field as shown in this table need to be tuned to make the lightning strike location data that captured by LDAS are closer to the lightning strike location data from Broadhead LD350 system. The result of FMS show the optimized PID controller parameters KP, Ki, and KD are obtained after run the ABC algorithm in 10 independent runs for each number of foots in each performance criteria. The PID control parameters is used to evaluate the step response characteristic of the half angle of FMS. The step response characteristic consists of rise time, setting time, steady state error, and overshoot. The step response characteristic for ISE is same for different number of foots that evaluate in the system. This means the ABC algorithm converges to the same optimal solution that generate the same result in optimized PID controller parameters and step response characteristic. ISE have the shortest rise time among all the performance criteria that evaluate in the system. This means that for the application that require faster starting time taken from 10% to reach 90% of the final value can use ISE with 10, 20, or 30 number of foot. However, the setting time and steady state error for ISE is the worst among all the performance criteria that evaluate in FMS. The longer setting time in ISE causes the time taken for the system to reach steady state and stay within 2% of steady state becomes slower. Among all the performance criteria that evaluate in FMS, only ISE has steady-state error. That means they have difference between input and output, although the PID controller parameters were optimized by using ABC algorithm, while the steady-state error for other performance criteria is 0. For RMSE with 20 number of foot, the overshoot and rise time is the lowest and highest in respectively among all the performance criteria that evaluate in FMS. In opposite, the highest overshoot is recorded in the RMSE with 10 number of foot, while the lowest setting time among all the performance criteria is recorded in the ITAE with 20 number of foot. Next, there are 3 conditions to analysis which performance criteria is most suitable to tune the PID controller for obtain the best half angle performance of FMS. Throughout the analysis, these 3 conditions show that the best performance criteria is RMSE with 20 number of foot. This is because of its lower overshoot compared with others. By comparing the same overall result, the worst performance criteria for FMS is RMSE with 10 number of foot. This is because it has the highest overshoots compared with others. In conclusion, the performance of ABC algorithm is tested by varying the difference parameters with different benchmark function. The objective value becomes lower when the number of dimensions decrease, the number of foot increase, and the number of iteration increase. ABC algorithm has successfully optimized the parameters that detect the lightning strike location in LDAS. These parameters include the peak voltage of electric field and magnetic field that determine the latitude and longitude for the lightning strike location. The optimized PID controller parameters for FMS is obtained by using ABC algorithm. 5 performance criteria are utilized to tune the PID controller in order to reduce the vibration motion of the flexible arm and optimize the performance of FMS. Generally, performance criteria RMSE with 20 number of foot recorded the best half angle performance of FMS in 3 conditions that evaluate in the experiment due to its lower overshoot. In future words, the performance of ABC algorithm can be investigated by varying more other parameters with other different type of benchmark function. Next, the variables that determine the type of lightning and the variable that calculate the power of lightning strike in LDAS can be tuned. Last, the PID controller that used in different systems can be optimized by using more different type of optimization algorithm. Here is few of the reference. Thanks for watching.